Hi guys, we are going to start graphing sines and cosines. Right now this would be a good thing to pause and take a picture of because I'm going to be using this terminology and these concepts as we go. And you can see that right here my sine and my cosine have a very similar beginning format, and we're just going to take it from here. So the first thing I'm going to do is establish what the parent function looks like for both sine and cosine. Because basically we're using a parent function concept for all of the graphs that we do. And there's a 1, 2, 3, 4 steps right here. Has it been amplified? Has it been flipped? That has to do with the a value in the problem. What is the period? How big are the increments? That has to do with the b part of the formula there for sine and cosine. So, like I said, take a picture of this. This is the outline, the overview. Let's begin. I'm going to start by graphing just a regular old sine graph. So, y equals 1 sine 1x. Now the thing is normally they don't write the ones in, neither will I, but I wanted you to see that my value here, if I take the absolute value of that number, that guy is called my amplitude. And that amplitude will tell me how high and how low my graph will go. That means when I sketch this graph, it will have a height of 1 and a depth of -1. That's what it means. Do you also notice how I took the absolute value of that number? See, the amplitude is a positive thing. It goes this high or this low. But some graphs are flipped. If something has been flipped, guess what? You're going to see a good old negative in front. But since we're not flipping this, I'm not going to leave that there. But the other thing is, you'll notice I drew my coordinate system so I have room on both sides. Well, the very first set of problems, they're going to ask us to graph over the interval -2 pi to regular 2 pi. That's what the instructions will say. So what they're going to do is they're going to have me graphing some of my information on this side. They're going to have me graph some of my information on that side. Just so you know, that's fine. That's totally common thing to do. But what's going to result is you'll see 2 periods of this function. Now let's talk about period. This number here is my b value. This guy will adjust my period. So this adjusts my period on this function. And period is always determined by 2 pi divided by b. In this case, they give me a 1. So guess what? My period is 2 pi. What that means is this graph is going to do its thing, start to finish, at 2 pi. That is the normal standard period for this function. So, you take the period times 1/4, always 1/4 because you break it into quadrantals. Well, technically we call them quartiles, but we're going to take this and multiply it by 1/4. I could then do a little cross canceling, and I get pi over 2. Now this is how big my counting pieces are, or we call them increments. So I'm going to say 1 pi half, 2 pi halves, 3 pi halves, 4 pi halves. Now, before I do this any farther, we would never say 2 pi halves. We would reduce that, so I'm going to get rid of the 2's there. And 3 pi halves is legit, but we would never say 4 pi halves. We would just call that thing 2 pi. So that's what they mean by you're going to graph to 2 pi. But going backwards, guess what? They want me to do on the negative side. Negative pi halves, -1 pi, negative 3 pi halves, negative 2 pi. So what's going to happen is you're going to see I'm going to graph one period of this function from here to here. I'm going to graph it on the positive side of the x-axis, and then I'm going to graph the other side over here. I'm going to graph one period on the negative side. And that's how the answer key is written in the book also. So grand total will have 2 periods. This from here to here would be 2 periods of this function, and one's going to be positive, one's going to be negative. But that's what they mean by this interval from negative 2 pi to 2 pi. Well, what does this graph look like? Well, here's what it looks like. It always starts at the middle. If you wanted to, you could punch these numbers in on the calculator. You could see that the sine of 0 is 0. And since it's in radian, every graph is done in radian. They're going to have this thing say sine of pi over 2. Guess what? You punch that in on a calc, you'll get the number 1. You punch in sine of pi, you'll get 0. Sine of 3 pi halves is negative 1. Sine of 2 pi is 0. So what happens is this sine curve looks like this. Now, it's supposed to be symmetric. That's kind of crap. I'm going to try that one more time, see if I can draw it just a little bit better. Oh, my gosh. Nah. One more time. One more time. Oh, man. I should have left the first one. Oh, my God. Here, I'm going to try drawing it backwards. Maybe that'll help. Okay, that's not... You know what? That's as good as it's going to look. So... going the other way, it repeats the pattern. If I wanted to, I could punch in the sine of negative pi halves. It'll tell me negative 1. Sine of negative pi, it'll say 0. Sine of negative 3 pi halves, I'd get negative, etc., etc. So what's going to happen is it repeats this pattern. Oh, that was way better that time. Much better. Look at the left side. That's how the right side should look. Very smooth. The curve should be very smooth and pretty, unlike the right-hand side of my graph. But this guy right here, this is what the parent function of sine looks like. This is y equals sine x. That's what we write it out as. You'll notice I left the 1's out because we normally don't write the 1's. So what are they going to do? Well, they're going to show me the parent function for sine, and then here, the parent function for cosine. That's the next one. So once again, I'm going to say y equals 1 cosine 1x. Remember, this guy's job is the amplifier, the amplitude. It's going to go as high as 1, as low as negative 1. This guy's job is to adjust my period. But if that number is a 1, that means when I go to find the period, it's going to be 2 pi divided by that number. It's always going to be 2 pi. If that's a 1 right there, my period will not change. So you'll notice when you graph all the first set of problems, they don't mess with the period at all. They mess with the amplitude. They do. But they do not mess with the period at all. Which means every graph I draw is going to do the same type of thing. And you check the answers on the homework. They're going to start at 0, of course. This guy's got an amplitude of 1, and it goes down as low as negative 1. The period means it'll do its whole thing between 0 and 2 pi. But how big are my counting pieces? Well, for all the first problems, I'm going to do the same thing. I'm going to end up with pi over 2 increments. So I'm going to say, oh, it's going to be a pi over 2. Whoop, oh my God, that's a 2. That looks like a z. Oh my God, pi over 2, pi, 3 pi halves, 2 pi. That would be one entire period of this function. So you know what? Let me just sketch this out. If you were to take your calculator right now, and remember it's in radian mode, I would say, what is the cosine of 0 radians? It would say 1. If I punched in the cosine of pi over 2, it would say 0. Cosine of pi, it would say negative 1, etc., etc. So you're going to hear me say this a lot. When you sketch sine, it always starts on the line. But when you sketch cosine, it starts above the line. So it goes above the line, on the line, below the line, back on the line, above the line. So that is one period. That is a standard one period of cosine graph. But what are they going to ask you to do in the book? They're going to say graph half of it on the positive side, graph half of it on the negative side. So let's just sketch this out quick. And we got one more in this section, then we'll do the next section. But it starts above the line, right? Then it goes on the line, below the line, back on the line, above the line. So it just repeats the same pattern. Sine, cosine, they are wave functions. So they just go, they don't go randomly. They go, that kind of thing. That's what they look like. I want to do that one more time because I like the sound effect. That's what it does. It's a wave function. But my wave that I just sketched was very crummy. This right here is a good look at the parent function of y equals cosine x. That's what it will look like over an interval of negative 2 pi to 2 pi. All right. So that's one period. Hang on, let me label this. That's one period. One of those was on the positive side, one's on the negative side. So in the very first section of problems, all they want you to mess with is amplitude and flippage. So I'm going to do this one for you, right? I'm going to say, let's take a look at this guy. And once again, what do? I take the absolute value of this number. So we say, what is the absolute value of negative 3? It's regular 3. So in the book, it'll say, what is the amplitude for each? Well, the amplitude is never negative. So we would never say the amplitude is negative 3. No. We would say the amplitude is 3. This graph just happens to be flipped. Okay? And since this number right here, I'm going to grab a different color. Since this number right here is a 1, that means my period is going to be 2 pi for a period because it's 2 pi divided by 1. Whoop. Here, I'll make it work. Period. And since my period's 2 pi, I'm just going to say, if I were to multiply that by 1/4, my increments, my counting pieces, are 2 pi units. Or, pi over 2 units. So, how does this graph differ from the two that I just drew? Come on, straighten out. Really? You're not... Straighten out. There we go. Here's how it's going to be different when I check the answer in the answer key. This one's going to go 1, 2, 3 units high, 1, 2, 3 units low. That's going to be the big difference. They're still going to have me count by pi over 2. There's pi. There's 3 pi halves. There's 2 pi. 2 pi. And then over here, I'm going to go backwards. Negative pi deuce, negative pi, negative 3 pi deuce, negative 2 pi deuce. No, sorry. I'll stop saying that. Negative 2 pi. But since it's been flipped, let's examine this. I'm going to scroll up a little bit here. Remember, the parent function for cosine x, it always starts above the line, not if it's flipped. If it's been flipped, it's going to start below the line. So instead of above the line, it's below the line. So I go below it, on it, above it, back on it, below it. So when I connect these dots, what's happened is this cosine graph has kind of been stretched out. It's been stretched out. Look at the notes that I gave you guys at the beginning. So that guy has been stretched out a little bit. And then if I go in this direction, keep the pattern. On the line, above the line, back on the line, below the line. And we just keep this flow as we graph this function. And there you go. That is 2 periods total. 1 period is on this side. 1 period is on this side. That's how the answer key is written in our book. And that is over the interval negative 2 pi to 2 pi. So I'm going to come back to this, but I'm just going to show you real quick. There's 2 sections in the book we're looking at, so I'm going to scroll up real fast. In the book, this is the section I just did, right here. Okay, this section is the section I just did. And this is section 4.1 in our book. This is section 4.1. Now, here's the deal. I do not want to get into this today, so I'm not going to have you do that. And then if you look, I was so kind, I already did number 20. That was the example I just did. So you guys are going to do 13 to 19 there. All right? And look, graph each function over the interval negative 2 pi to 2 pi. Give the amplitude. So what does that look like? Well, look. Here's the answer key for those. There's only one thing that they did that annoys me on this, is since the period is always the same for these first couple problems, they didn't mark every quartile. They didn't, but they should. They really should mark every quartile. If you guys do the homework and do not mark every quartile, I will take points from you. So please do that. Also, here's the amplitude. Like I said, the amplitude for the problem, they're always going to write it in as a positive number because amplitude is always positive, even though a graph could be flipped, right? So here's the answer key for 13 to 20, but you don't have to do number 20. I already did it as an example. And then, here we go. We're going to start looking at what happens when you do affect the period. See, these ones here, this is the second part of your stuff. This is still section 4.1 in our trig book. But here, look, all of these now, those aren't ones. Those are different. So our period is going to change. Period adjustment is not a big deal, but they also say graph it over 2 periods. So let me show you a couple of these, and then you're good to go. You should be fine to get this lesson just knocked out, because I don't think you're going to have a big bunch of trouble. But I will warn you about this. When you see a fraction, most people panic when they see a fraction. Fractions are actually easier than whole numbers. I'm not kidding. I'll do the first one I'm going to do is going to be a fraction-y type problem. And then the second one I'm going to do is going to be a whole number. You'll see the ones with fractions are actually easier. So here we go. I'm going to do one with a fraction. Whoop, let me get down there. So here's where we left off. I would like to do this example right here. I'm going to kill 2 birds, 1 stone. I'm going to amplify this, but I'm also going to period adjust it. So, look at my graph. This is going to be my amplitude adjustment. So when I sketch this graph, it's going to go as high as 2, and it's going to go as low as -2. I'm still going to have some increment adjustment. I'm still going to have increments here. I will. But you know what? This is not a 1 this time. So I'm going to have to do my period is based on 2 pi divided by b. Now, 2 pi divided by 1/2 is the same thing as 2 pi divided by 1/2, which is flip and multiply. Guess what? Your period here is 4 pi. So 4 pi times 1/4 gives you pi increments, meaning your graph is going to start at 0 and then go 1 pi, 2 pi, 3 pi, 4 pi, stop. That's where I stop. I stop at 4 pi. My period, this graph will do its thing between 0 and 4 pi. So if I were to sketch it, I would say it hasn't been flipped. It is a cosine graph, so it's going to start above the line. Then it's going to go on the line. Then it goes below the line, back on the line, above the line. Cool rhythm. And then I'm going to just connect these dots with a smooth curve, try and do it the best I can. And right there, that's one period of this function. Okay? But the book is going to ask us for 2 periods. They do. So the book did this. They graphed one on the positive side, and then they worked backwards. They did one on the negative side, which is fine. It's not wrong. It's not wrong. But always sketch one period completely first, and then go back and sketch in your other period. Sometimes the book will ask for 2 periods. Sometimes it only asks you for 1 period. And I can tell you right now, when I give you the test on this section, I will specify. I'll say graph this over 1 period, graph this over 2 periods. And if you graph 7 periods or something, I will totally mark you wrong. I need you to understand the vocabulary involved in this process. So, let's go for one more. That one had a fraction in it. Let's do one that doesn't have a fraction in it. So let's do something like this. Y equals negative sine 3x. And that's a whole number, and that's a negative 1. But that does not mean my amplitude is negative. My amplitude is always the absolute value of that. So they say my amplitude here would be 1 unit. So I go up 1. I go down 1. 0 in the middle. But this thing does tell me that I am going to flip my graph. That's what that guy means. But let's find my period. My period would be 2 pi divided by 3. Hey, guess what? I just took a shortcut there. I didn't write out all the fancy stuff. I just said, hey, if this is my b value, then that's my period right there. So it's going to start at 0. It's going to go boom, 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 stop at 2 pi thirds. That's what's going to happen. How big are my counting pieces? My counting pieces are always found by doing whatever the period is times 1/4, and then I can go like that, I cross cancel. So it's going to be pi sixths are my increments. So I'm going to count by pi sixths here. I'm going to start on the line because it's sine, but normally sine goes up and goes like, up, whoop, I'm going to get rid of that. But this has been flipped, so it's going to go down. Then it's going to go up, or on the line. Then it's going to go up, and then it's going to go on the line. So when I sketch this graph, it goes like this. That's what it looks like. But don't make a rookie move. Tell me what these increments are. Oh, yeah. That's pi over 6. Now, I could call this 2 pi sixths. I could call this 3 pi sixths. I could call this 4 pi sixths because I'm counting by 6. Those are my increments. But we never do that because we reduce our fractions. We're polite. So instead of 2 pi 6, guess what? I would have called that pi over 3. That's what I would have called that. Instead of 3 pi sixths, I would have called that pi over 2. And you can see that 4 pi 6 reduces to 2 pi thirds. So don't forget to reduce things. Now that I have one entire period graphed, one period is already done, it makes it easy. Just work backwards. I'm going to go negative pi sixths, negative pi thirds, negative pi halves, negative 2 pi thirds. And follow the pattern. I stopped on the line, so I'm going to go above the line, back on the line, below the line, then on the line. And I just keep the pattern going because it is a wave function. And there you go. There's one more period of this function. One more period of this function. 2 periods total. All right, guys. You got the idea, I'm hoping. And if not, remember, ask me questions in the Zoom room. But here's the second part. Here's the second part of things. There's the answer key for it. So the second part of stuff, this is section 4.1 in the trig book, 23 to 31. Sketch these graphs for me. They all have period adjustments. Do them over 2 periods. Remember, that's the answer key for the first part. Here's the answer key for the second part. I wanted to make sure you could read it, so I separated this thing. But you will notice here, like this guy, they didn't write in these missing pieces of the puzzle. When they sketch their graphs, they're sloppy. They give you this one right here. They said 3 pi halves. They gave me this one right here. They said 3 pi. But you know what? They did not write this one in, 3 pi fourths. They did not, which makes me upset. They did not write this one in, 9 pi fourths, which would be the name of this quartile. When you guys check your answers, I want you to know that the answer key in the book, they did not write in every single number. They should have listed every quartile. Just because they did it wrong doesn't mean you should do it wrong. Give me every piece of the puzzle, every quarter. Show me your increments. Okay, and then scroll down. There's the end of that one. Take a picture of it. You can check your work then. Other than the quartile thing, they did everything else nice, but don't develop a bad habit. Develop a good habit. All right, so guys, answer key, questions, there you go. Remember, that was the answer key from the other ones right there. And then there's all the practice we're going to do for this first section. All right, draw me some beautiful pictures. Get out that ruler. Okay, thank you. Bye-bye.